Hey everyone, and welcome to Dr. Abu RTN Academy channel. Today we are going to discuss part 5 of descriptive statistics of the subject of biostatistics. In this video, we'll start with the outlier. Outliers mean something which is outside the normal, something external, outside the normal. For example, if I have a group of people, 12 people, 10 people gathering together and one person is standing very far from them, so I can call him outlier. If I have another one standing at the other side, but away from the group, I can call him outlier. So outlier is deviation, something which is not in line with the whole group. So I can have the distribution together in one place or some normal scheme or common scheme, but I have one person or one parameter which is odd, which is not part of the whole or common scheme of the distribution. So we are calling them outliers. Outlier means they are not normal, they are not along with others, they are far away. Okay, so outlier, an important kind of deviation, okay, is an outlier. Outliers are observations that lie outside the overall pattern of the distribution. Okay, always look for outlier and try to explain them. When you find outlier in your distribution, usually either you, as part of your investigation and withdrawer of a conclusion, you have to explain why these outliers exist, or you have to mention them, or it might be requested by the professor that you, in the question set, that you explain why these outliers are here. Okay, so for example, if we look at this graph, which we have this histogram, which we have here the number of states in the United States, and here the percentage of the state residents age 65 and over. Okay, so here we have the number of states, it's only one. Okay, so one state here, and also this one is one state. If you look at the rest of the histogram, the distribution, I can see here that I can draw this like symmetrically distributed histogram. Okay, so it's almost like, so we can say it is fairly acceptable that it will be symmetrically distributed histogram. Okay, but this one and this one are outside the distribution, the pattern of the distribution. So this is the main pattern of the distribution, but these two are outside it. They are not matching with the distribution or the pattern of the distribution. Okay, so that's why you call them outside the overall pattern of the distribution. Always look for these outliers and explain them. So if we look at these, okay, outliers, I have two outliers here. The number here is 1, so it's one state, number of state, one state, and this one also is one state. So both of them are one state. So I can't even give the name. He already gave me the name. He said this is Alaska. So Alaska state in the United States of America. Alaska state, they having 5 to 6%, okay, of the residents aged 65 years old or over. Okay, so it is very low percentage, because here the population, or we can say the distribution or the common pattern, start from 8 up to 16. Okay, so we can say that, okay, in the United States between 8 to 16% of the people are aged 65 and above, but here 5 to 6 is applicable only to Alaska. So Alaska is unusual, unnormal compared to the whole population here. Okay, or the trend or the pattern. So Alaska unusual. Florida also unusual, because in Florida the percentage is between 18 to 19, which is higher than even the maximum which we have here. So these two are odd, they are different, they are not matching with the pattern of the distribution. The overall pattern is fairly symmetrically, so it is acceptable. Fairly means acceptable. Symmetrical, okay, we can see it is almost symmetrical. Okay, fairly symmetrical except for two states clearly not belonging to the main trend, which is Alaska and Florida. Okay, Alaska and Florida have unusual representation of the elderly, okay, in the population. This is the interpretation which I can give, that I have two states, Alaska and Florida. They have unusual representation of the elderly in their population. So in whole the states of America, the percentage between 8 to 16, except for two states, which one of them which is very low and one of them which is very high. Okay, so they are unusual compared to the whole population. Okay, always when we find the large gap in the distribution, this gives us indication that we have outlier. Okay, so here I have gap. If I can erase this one, you can see the gap. So here I have gap, and also here I have this gap. Give us indication that we have outlier. Okay, it is a typically sign of an outlier. It gives us indication. Sign means indication of availability of outlier. Okay, so here coming to the point how to create histogram. There are some criteria or factors we have to consider or to take into consideration when we decide to create a histogram. First of all, that the histogram should be clear. So someone will create a histogram like this. Okay, this is summarized. Okay, it's called summarized. Summarized means it is very clear. It can be visualized very easily. We can identify that we have, okay, recognize that we have 3 areas, very clear areas here. Okay, but it doesn't give the details what's inside this area. So it is like we put them in all these items which are here, we put all of them in a bag and we close the bag, so we don't know a lot of details about them. We group them so we cannot benefit from them as much as we can. But if we have more details, maybe it will be better, so we can put them in a better classifications or better classes, smaller classes, so we can get the benefit of them, analyze the data more accurately and arrive to more precise conclusion or withdraw more precise conclusion from the data. But now we can say, okay, we have only 3 categories, so we'll have only the conclusion about these 3 categories. But in reality, we have subcategories inside this one. We may end up with having this category, another one here, another one is more here, so we don't know what is inside this. So here we already summarized all of them and wrapped them up, so we don't know what is inside this block, what is inside this block, what is inside. So it's called summarized. In this case, if we summarize them widely like this one, so we cannot benefit from the details inside each block or inside each class. Okay, but it is good that we can visualize it very easily. There are 3 categories only, we can visualize them very easily and we can derive a conclusion, but this conclusion will not be so detailed or so precise. So if we looked here at this 3 histograms, the first one which we have here, this histogram, it is very summarized, so we can arrive to a conclusion. This block is within this range or represent this sample, this block represent another sample, and this is the conclusion, and the third one represent another sample, and this is the conclusion of it. It is very easy because only there are 3 blocks and there are 3 big and unique blocks. So we knew that, okay, the first block is up to this height, the second one is more than the first one, the third one is smaller, and that's it. On the other hand, we can have a very detailed one, so each and every section or every and each class which we have, it is very detailed. I can talk about this small sample, this is the range of it, and this another small sample, another small sample, another small sample, another small sample. So I sliced it into small, very small samples. Okay, so I can talk about each and every small, but now it became very detailed. There is no big difference between it and the table. If I have a table and just you listed down the data 10, 15, 16 and so on, 20, 21. So there is no too much benefit. It must be summarized, and at the same time it must have enough detail. So our rule here is to have a compromise, or to reach something in between, something reasonable, okay, acceptable between. It should not be so detailed, and also it should not be so summarized. It has to be something in between, has enough details, and at the same time it is not very detailed like each and every element. Okay, so here, how to create the histogram. It is iterative process, so we have to try to repeat and to check whether it is right, or we need more detail, or it is very detailed and we need to summarize it a little bit. Okay, so it is iterative process. Try and try again. Try and check what you have done, and then try again. See the numbers of the pins, or the number of the clusters, or the number of sections, or the number of the classes which you have chosen the right number or no. Okay, this is one of the schools. Say try and try again. There are some other schools that said no, we have to set rules how many clusters or how many classes we should have, and what is the width of the each pen, or each cluster, or each class, what is the width of it. So here what we are going to discuss. So if you look at this one, what is the pen size? What is pen? Is this the pen? Someone will laugh and say, hey, it is this pen, okay, or the garbage pen. Yes, it is like the garbage pen. If you have the garbage pens, okay, a set of them, one of them for paper, one for clothes, one for paper, one for clothes, one for glass, and one for plastic, one for books, and whatever. So if you merge all of them in one big bin, then it is very difficult to segregate them later on, and it's very difficult to say how much books we have, how much plastics we have, how much glass we have. So it will be very difficult to judge. But if you have a separate bin for each type of the material, it said, okay, the second one, which is for plastic, is full, so I have a lot of plastic. The third one of paper is half, so I have half of the bin for paper, so I have more details. So if you have more than one bin, then you can say one for paper, one for plastic, for example, one for glass, and you can open it and just see the details. The glass is almost 20% full, okay? The plastic is half, for example, half, so you can say 50%. Here, 20% full. The paper is full, 100%, for example, okay? 100%, it is full. So it is easy to judge, but if I have one block, if all of them are merged together, all the blocks are merged together, I can say, okay, I have up to here, it is full of glass plus plastic plus paper. I cannot judge whether the glass is more, or plastic is more, or paper is more, and I cannot get the details inside each box. Okay, or the details of the material which I have gathered. I don't have the details. Okay, but if I divided them or sliced them into classes or into pens, so it's easy to judge for each one. So here I have to compromise. Okay, someone will say, I don't need to talk about only paper. Someone will say, okay, the paper one, this is, for example, for paper. He said this paper, instead of having one pen, I'll get two pens, okay? One pen here for the box, and another one for individual papers, okay? Separate paper, individual papers. So I can get the details of the individual paper, the A4 or A3 paper, the trash paper, and here the box, okay? Box also consists of, or comprises of paper. So how many books I have and how many individual paper. For the glass, someone will say, okay, I have water bottles in this section, and here I have the flat glass here, or the broken, or the pieces of the broken glass here. So I can get more details, and the same thing for the plastic. So I can split these pens into more. I can split into each one of them 3-4 categories more. Okay, sub-classified them. So what level of details I need? This is the point here. If I need all these details, I have to put them, but I have to be careful that if I put a lot of detail, it will be converted like a table. So there is no meaning of summarizing them or putting them in histogram, because I lost the purpose of histogram visualization. That from the first time I see visualized the histogram, I can judge, I can see how the data is organized and how the data are varied. So if I put all details, I lose this purpose. Okay. Also the same thing. If I summarize all of them, if I put all of them in one pen, there is no benefit. I see one block, I don't know what's inside the block. Okay, material, glass, paper, whatever plastic, but I don't know what is inside these pens. Okay, so I lost the purpose. So I have to compromise. Compromise means reach a balanced agreement. Okay, someone give and take. Okay, I need details, but at the same time I need to be summarized. So what is the best way to have a histogram which is summarizing and at the same time has enough details? This is the point. So here in this slide, it talks about iterative process. Try the number and the width of each class and the number of classes or number of pens required, and try again. Okay, so here, what pen size should we use? Okay, when we come to select the pen size, there are many schools in this. So here, in summary, these are the condition or the criteria which we have to consider as per this slide. It should not be too many pens. Okay, I should not have 30 or 40 or 50 pens. So I should not have 100 pens. Okay. It became like a table. Okay. So I should not have too many pens. Okay. It should not be over summarized. I should not have 2 pens only and say, okay, this 2 pen is my data. So all the details are inside. I don't know what are the details. So it is very summarized. Okay. Or you call it overly summarized. Okay. It is over summarized. So there is no details here. Okay. Here I have a lot of details, but it's meaningless, because I cannot have 500 description or 200 description or 100 description or 50 description. So I should summarize that in the first quarter, what happened, second quarter, what happened, third quarter, what happened, the fourth quarter, what happened. In the first 50% of the sample, what happened, in the last 20%, the last 10%. So it could be 5-10 clusters or 5-10 classes. In some cases, it could reach up to 20. But this is for the very big samples, okay? But usually we have between 5 to 10 classes. So we should not have overly summarized like this one, only two blocks. So this is overly summarized, which doesn't give any details, okay? Or only very limited details, to be more precise, okay? It will be give very limited detail. Also, we should not be very detailed, okay? Not so detailed, so it is no longer summary. It became like a table of hundreds of data or tens of data. So what is the benefit of the histogram? No summary can be drawn from the histogram. Okay. So if we looked at this example which we have here, I just extracted from some videos. Here I have this number of pens or classes. So I have the first class or the first pen, second pen, third pen, fourth pen, and so on. So this number of pens, usually because you have your graph paper, it is split into square, and each square is 5, and then here 5, and then another 5, so it would be 10, another 5. So 5 is small square, sub-squares here, 5 sub-squares here. So better always when we have this cluster to have it tens or 5. So if I, for example, okay, I can start from here, from 0 to 5 to 10, 15, and so on. Okay, 15 and so on. Or I can make them 0, 10, 20, 30. So my pitch, okay, or my step of each class, or the width of the class, the width of the pen, okay, should be always 10 or 5. Okay, could be 20 or 30, But in the examples which we used to get in the university, the sample should be around 20 sample up to 100 samples. So if it is a matter of sample of 20 variables or 20 readings or 20 measurements, okay, so we can have the class width 5. If it is 100 variables, 100 measurements, so we can have a different one. But I will come to the example which make it more clear now. But before coming to the examples, I just want to mention here that, okay, the pens which I have, this pen and this pen and this pen, and so each pen of them should be of the same size. So here, this is the width of the pen, the width. So the pen should be of the same size, okay? So if I move here 10 centimeter, 10 centimeter, 10 centimeter, 10 centimeter, 10 centimeter, 10 meter, 10 meter, 10 meter, 1 centimeter, 1 centimeter, 1 centimeter. It depends on the scale which you are using, okay? It could be 20, 20, 20, 20, and so on. So the pitch, okay, of each pen should be the same, okay? Or the width of the sample should be the same. The width of the pens should be the same, okay? Any terminology which you want to use. So pen should be of the same size, okay? Each pen should be of the same size. We have to make sure that this pens covers all the data. So if I have data from 1 to 100, I have to make sure that all this data will find the places in these pens which we have selected. No, so if I say here up to 100 and they have a data of 113, so where can I put them? I don't have space or place a pen to put them here. So I have to make sure that all the pens which I have selected covering or including all the data. If I have one and start the pen from 100, so where I have to put one, I cannot find the pen to put one in. So I have to make sure that the minimum value and the maximum value, all of them are included inside, they are having a place inside these pens, okay? So this pen should include all the data. It is better to always to use whole numbers, integers. Don't use 10.15 in your scale here. So here 10.1, here 11.3, and so on. No, better to use whole numbers, integers. So we can use 5, 10, 5, 10, 15, and so on. You can use 6, 11. So every time incremental you have 5 increase. So 5 plus 11 equals 16, 16 plus 5 equals 21. So it should be whole numbers, okay? It's not must to be 5 and 10, it could be 6. It could be also anything else. It could be, for example, 11, 21, 31, 41, 51, and so on. So the difference between them, 10, 10, 10, 10. So we have the same size. The minimum data should be within the first one. The maximum data should be within the last one, okay? So it should cover the data, okay? It should be whole number, should not be decimal. And the number of pens usually between 5 to 20. If it is more than 20, it will be horrible. It will be like a table. You cannot get any data, any summary from it, any conclusion, okay? So if it is more than 20 pens, it will be like more detail, much detail, so you cannot withdraw any conclusion or cannot get a summary from it. If it is less than summary, okay, in some cases 2, 3 pens, it's okay, fine also. But if it is 2, 1 or 2, so it is very summarized, you cannot get any or withdraw any conclusion of it. So let us take this example in order to wrap up our minds. I have a sample or the result of an experiment start from 1 up to 50.5, okay? So in order to make sure that I'm covering the minimum and the maximum, so I have to get the minimum and the maximum and subtract them. So 51, as I said, I should use whole numbers only. So if I said 50.1 minus 1, it will give me decimal. So better to round it up, not only round it to the nearest one, round it up, increase it, okay? So I write 51. Okay, instead of 50.1, I write 51. Minus 1 equals 50. So this is my range. The maximum, minimum, the maximum minus the minimum. I have the range of 50. As I said, for a small sample, this is a sample of around 20 reading or 20 measurements. So I can use 5 pens only. Okay, 5 pens will be more than enough to group all this. It's 5 pins would be enough to put all this data inside the pins, okay, to group them in. But if it is 100 reading, so better to use a wider number of pins or larger number of pins, which could be 10 pins, could be up to 20, but usually we use between 5 to 10. Okay, so if I divided this, the difference here is 50. If I divide it by 5 pins, okay, if I want to put in 5 pins, okay, so 50 divided 5 equals 10 pins. Sorry, I have 5 pins. Okay, I have 5 pins. So 50 divided 5 pins equals 10. So 10 will be my pitch, my class width. Okay, so I draw the histogram, and I make my pitch or my class width, 10. Okay, because I have 5 pins. Okay, it is a small sample. I said, okay, I have 5 pins. So since I have 5 pins, I say that the range which I have is 50 divided 5. So I need the width of each class should be around 10. Could be 8, could be 6, but it should be constant, okay, 10. So I start from here. So the first point is 1. I can start from 0 and put 10, okay, or I can start from 1 and put 11. So I can start 0, 10, 20, 30, 40, 50, but in this case I have 51, so I have to make another one 60, okay? Or in order to have a better summary, I don't have 0 figure here in the readings, so better to start from 1. Why I have to start from 0 if I don't have 0 in my measurement? So I can start from 1, and my pitch is 10, the class width is 10, so 1 will be 11, will be 21, 31, 41, and then 51. I have the biggest number is 51. Then I can represent them. I can count how many between 1 to 11, how many, the frequency, how many numbers between 1 to 11, between 11 to 12, 21, between 21 to 31, and so on, and I can start drawing it, okay? So in this case, as we said, that we achieved all the 4 criteria, that the bin should be of the same size, okay? The class width for each of them is 10, 10, 10, 10, 10, the same size. It includes whole data from 1 to 51. All the data are covered. Use the whole number. There's no decimal. I didn't use any decimals here. It is the number of bins between 5 to 20. Yes, I have chosen 5 already from my mind, okay? Just to make sure that we fully understood it, I have given this example also. So I have this quiz scores, okay, which 22, 25, 18, 19, and so on, up to 18 and 25. So I have 20 numbers of students, 10 here and 10 down, so 20 number of students, and these are the results of them. So if I want to draw a histogram to represent this data, so what type of histogram or how many pins I have to draw in this histogram. So as we mentioned, first of all, look at the minimum number which we have here. The minimum number is 11, okay? So 11 is the minimum number, and 30, this 30 or this 30 in one of them is the biggest number. So the range, the minimum 11, the maximum 30, okay? So the range will be 30 minus 11 equals 19. Okay, so my range is 19, and these are only 20 results, 20 reading, 20 measurements, so I prefer to use 5. For the small samples, use 5. If it is 100 or 80, you can use up to 10, okay? So 19 divided 5 equals 3.8, which is approximately 4. We round it up always, okay? It's 4. So now I have decided to use 5 bins. Okay, so I put all data in 5 bins. Okay, all this data I put them here in 5 bins. Okay, and so on. Okay, so I'll use 5 bins, and each bin width will be 4. So the distance between the first and second, 4, 4, 4. So it will be the same size. Okay, 4, and so on. So shall I start from 0 or shall I start from which one? Okay, look at the smallest number which I have here. The smallest number which I have is 11. So I can start from 11. Why I have to start from 0? So I can here start from 11. Then I add 4 to it. It will be up to what? It will be 11, 12, 13, and 14. Make sure that 11 is counted. 11, 12, 13, 14. These are 4 numbers. Okay, 1, 2, 3, 4. So it will be from 11 to 14. Okay, then I add another 4. It will be 14 to 18. 18 to 22. Okay, and so on. So here 11 to 14, then add 4, 18, 22, 26, and 30. Okay, so if I want to write them as pens, so I write, okay, use the smallest one, 4, then 4, count 4 in my hand. 11 is counted with me, so 11, 12, 11, 12, 13, 14. So start from 11 to 14. Okay, I don't have any decimals here, so I can use the next number. No need to use 14.1, 14.2, because I don't have decimals or fraction in my read. If I have decimal or fraction, I have to repeat the same number, but I put more than, greater, less than or equal to, or less than only. Okay, but here I have 4 numbers, so I start from 15, the next one, because I don't have decimals. So 15, 16, 17, 18. Okay, and then the next will be 19 up to 22. So from here it will be easier. Okay, so here 11, just first one will count it on your finger that you have 4, 11, 12, 13, and 14, and then add 14 every time. 14, 14, sorry, add 4 every time. 4, 4, 4, 4, 4. Okay, then count how many falls within 11 to 14. Then you'll find only 2. 11 to 14, only 2, which is 13 and 11. So these 2, I'll put 2 here. 15 to 18, I found this 3. 19 to 20, I found 6, and so on. Okay, so this is the way we are grouping the data into pens, and how we can determine the number of pens. Number of pens, usually we use 5 to 10, 5, 6, 7, 8, 9, 10. This usually what we're using. It could be 4, could be maybe 11. In some cases, it reach up to 20. If you have a big sample, maybe 200 readings or 200 findings, you can, or 1,000 or findings, so you can use 20 pens. So, but usually in most of the exam examples, even for the paper size of the exam, it is between 5 to 10. Okay. So as I said, I prefer when we have a small sample or sample of readings or measurements to use 5 pens only and put everything inside the 5 pens. Okay, but there are some other, and when we have a big sample, we can use up to 10, and in some rare case we can use up to 20. Okay, but I prefer always between 5 to 10. Could be 4, it's okay, could be 11, but the range of 5 to 10 is more reasonable range to cover most of the available samples and data which we have in our field. Some of the scientists said, okay, we should not leave it for the people choice or randomly. We have to fix or to set a rule for it. So there is a scientist called Sturges. He put some rules called Sturgis Rules. Okay, the Sturgis Rules say that, okay, the number of pens, we should not leave it to the people to determine whether they are 5 or 10 or 7 or 20 or 8 or so. He said the optimal number of classes or pens, okay, the optimal number of pens or of classes. So in the histogram, I have this class, the other class, the third class, okay, and so on. So the optimum number of these classes So here Sturgis rules say that in order to get the number of bins, okay, or the number of classes, K, which is number of bins or number of classes, okay, we have to find the total number of the measurement which we have, this, how many readings I have taken in my experiment. In my case, I have 44, okay, up to 44 here. So it will be 1 plus 0.33 log 44. So Sturgis rules say that 1 plus 3.3 log and the number of readings or measurements or observations. In my case, it is up to 44. It is not appearing here, but it's up to 44. Even if you consider up to 19, just it will be log 19. Okay, so 1 plus 0.33 log 19 or log 44 and so on. So for example, you arrive to 4 point something, 4.5, 4.2, 4.0, so you round it up to the next one. So it will be 5, for example, or 6, or 7, and so on. So now we'll get the number of bins. How many bins you will have, okay? So the number of bins which you will have, okay, we'll put our stuff inside it, our measurement, our reading, okay? This is the number of bins, number of bins, okay? So after we get the number of bins, we need to find the step, the pitch, okay? The width of each class, okay? So in this example, we will follow Sturgis rules, okay? I just extracted. So as I mentioned that we have the sample up to 44, okay? But because of the page size, we just printed out up to 19, but it's up to 44. So in the number of sample or the sample size 44. So Sturgis rule say that K, the number of bins equals 1 plus 3.3 times log and the number n which we have here, which is 44, okay, 44. If we calculate on the calculator 1 plus on the calculator 3, and then we have a log key in the calculator called log 44, we'll get the result 6.4, okay? Here, because the example was using the Excel, so it's calculated automatically, so n is 4. Here, this formula, how to calculate k using the Excel, okay? So the answer was 6.42, which is the same as our answer, okay? So now, we have the range, the smallest number and the biggest number. The smallest number was 7, okay? Minimum number, okay, was 7. And the maximum number, it's not here, but is appearing in the next slide. It was 59, okay? So the range which I have here is 52. So if I said the range 52 divided, I have how many pins I should have? 6.42, okay? So each pin width or class width should be 52, the range maximum minus minimum. The range maximum, which is 59, minus the minimum, which is 7, okay? Give us the range, which is 52, divided how many pins, okay? Theoretically, as per the calculation, as per Sturgis rule, it is 6.42. Of course, we don't have number of pins 6.42, okay? So divided 6.42, okay? So here, if we erase this one and we wrote here 52, so it will be 52 divided, which is the range, divided 6.42 gives us 8.09. We cannot have a step of 8.09, and so we can have 8, we can have it 10, we can have it 5. So better, because you know that our graph paper, it has sublines, okay, subdivisions always up to 5 or up to 10, so better always to use 5 and 10, so we can plot our reading or our measurement on the exact line. So it will be easy if we use our step 5 or 10 or similar thing. So here, since 8 is closer to 10, so we are going to use it 10. Okay, so the data will be grouped into tens. Okay, so we'll have the first step 10, 0 to 10 or 1 to 11, whatever, and then 20, 30, 40, and so on. Okay, so the number of pens in this case, it will not be exactly 6.4. It might be 5, it might be 6, it might be 7. Okay, it depends on because we have made some rounding here in the class width. Okay, so it may be less. Okay, so in this case, it may be 5 pens only. Okay, I hope this one clarified this point also. So coming back to our slide again. Okay, so we have to make sure that we don't have too many pens, 30, 40, 50. We should have limited number between 5 to 10. Okay, it's up to 20. If we have a great number of reading or measurements, it should not overlay, okay, overly summarizing. So it should not be one block or 2 blocks only. It should not be very big, 1 or 2 blocks only. And also at the same time, it should not be very, very detailed. So we'll lose the intention or the purpose of having this histogram. Okay, it should not be very detailed. Okay, we have hundreds or tens of bars in the histogram. It also doesn't work. Okay, so the third thing here, that it should not be detailed, because if it is too much detail, this means there's no summary. We cannot get a conclusion out of it. It is like a table, became very detailed like a table. The intention of the histogram is to group the readings, to group the observation, the measurement together, then we can arrive to a conclusion. This group follows this way, the other group follows the other way, so we can group them. But if we have them, all of them detailed, so what is the benefit of having the histogram? Also, if we overly summarizing them, so we'll have one block. So what is the benefit? We should have some details. So the point here that we should compromise. Compromise means reach a reasonable agreement between the clear presentation. How it is clear presentation? If I have 2 blocks only, it is very clear. Okay, in the histogram, it is only 2 blocks, very clear. So this is clear presentation, which is very good and very nice, but there is no much details here. So between the clear presentation, but a small number of intervals. I have only 2 intervals here. Okay, 1 interval, 2 interval, 1 class, 2 classes. Okay, intermediate class here. Okay, so I don't have enough details. So this is clear presentation, which is a small number of intervals, and the accuracy, okay, the large number. If I have only 2, I don't have accurate details. So when I take any readings from here or I arrive to conclusion, it is not so accurate. Why? Because I have lumped or gathered or combined a lot of data in one block. So this block does not present all the data inside it in details, but overall it's okay. But it is not so accurate. If I want to pick up one area here and to talk about the data here, it is not clear, it is not accurate. So I have to take the conclusion on the overall bar here, overall block which I have, including this one. So data will not be so accurate. But if I have detailed one, okay, the data will be very, very accurate, but I may find it not friendly user to present it, okay? So if I keep having 10s or 20s or 15s of the bars here, it's too much details. Each and every data here in this point, or this point, or this point, it will be very accurate, precise, but the way I am presenting it, it's not summarizing anything, it is not clear in the presentation. So I have to compromise, reach something in between. Compromise means I have to give something and take something. I have to compromise, to give and take, okay? I should not take everything one way and leave everything in the other way. I should reach something in between. This is called compromise. I have to compromise between the clear presentation. Should be clear. Maybe it's only 3 blocks or 4 blocks will be enough, or 5 blocks will be enough. Maybe 6 or 7. So it depends on my data. So I should have a clear presentation, small number of interval. As much as we make small number of interval, it will be good as far as all the data are captured and the details are available. We did not miss them. Okay, so I should have clear presentation, small number of interval. At the same time, I should have large number of interval to make sure that I have the accuracy. So now I'm fighting between two things, whether to have a lot of detail or a lot of clarity, okay? Summarizing here, summarizing more, a lot of summarizes here, so everything is summarized in two blocks only, and here everything is detailed. So which one I have to take? I have to reach a compromise. So it is case by case, okay? So here we came to the rule of Sturgis rule. He said the optimum, Sturgis rule, he said the optimum number of bins, okay, of bins or observations, the optimum number, it will be k equals 1 plus 3.322 log n. Forget about 10. In the calculator you find it log 10 or log only, it is the same, okay? 1 plus, so k equals 1 plus 3.32 log and the number of observation, the number of measurements, okay? This is called what? This is called Sturgis law. Accuracy we have taken that we have to compromise and reach something reasonable between the more detailed one and the less detailed, the summarized one. The class interval should be always the same. So in all the cases, all the scenarios, okay, when I have this class interval, I have to make sure that the class intervals which I have are equal, okay, from 0 to 20, this is first interval. Second interval from 20 to 40, the same 20, jump 20 again 60, 80, 100, and so on, okay? This is merged, but at the end of the day, it was 20, okay? 20, but because the size is up to 40, but there is 20 in between, okay? So I have to make sure that every interval which I have of the same size, 0 to 20, even if I'm not using it, like this one, I'm merging it, I'm using from 2 to 40, but I have already, in the x-axis, I have from 0 to 20. So every step equal 0 to 20, 20 to 40. I cannot have 0 to 10, then 10 to 30, or 10 to 40, and 40 to 70, for example. No, all of them should be equal. Okay.